So homework 11.5. Now, as I do these, yeah, I just spelled that on YouTube. I think about the bell curve. That's what I do. I think about the bell curve. The empirical rule that we studied Monday has 68%, 95%, and 99.7% written down. So I'm looking for those numbers. If I see those numbers, I use a formula. If I don't, I use a TI-84. That's how I'm going to do these. So the first one has 98%, which is not on the empirical rule. So I'm going to use a calculator. Let's see here. 20 randomly selected managers, that's the sample size, N is 20, were found to spend a mean time of 2.4, that's my X bar. Standard deviation sigma, there's no way I'll be able to type a sigma quickly, we'll see. Yeah, it's always going to do the other ones. The software man. Sigma is 1.3. Now I'm supposed to construct a 98% confidence interval for the mean time spent on paperwork by all managers using the sample. Alright, so I'm going to click Stat Calc. Sorry, tests, and I'm going to go to Z interval. That was Stat Tests Z interval. And I'm just going to put in the stuff that I have. I'm going to be using descriptive statistics, so I'm going to highlight stats. And the standard deviation is 1.3. The mean was 2.4. And the sample size was 20. The confidence interval was 98%, so 0.98. And I scroll to calculate. And there you go. That is the 98% confidence interval. So we are 98% sure that the population mean lies in that interval. That's what that means. And again, in words, we are 98% confident that the true population mean lies between 1.7238 and 3.0762. Alright, this one has 99.7 in it, so I'm going to use the empirical rule. Your confidence interval is going to be the mean plus or minus some number of standard deviations divided by the square root of the sample size. Now 99.7% is 3 standard deviations. Alright, so let's scroll through here. A mean of 5.15, standard deviation is 1.68. So 3 times 1.68 is going to be divided by the square root of the sample size, root 4400. And what I'm actually finding here is I'm actually finding what's called the margin of error. Alright, that's what this is. And this is push buttons. That's what it is. 3 times 1.68. That is divided by the square root of 4400. This is the old school way of doing things. It's what the state expects you to learn. 0.0760. So I am going to be the current mean, 5.15 plus or minus 0.0760. So let's see what it is. 5.15 minus that thing, 5.0740. The upper boundary is going to be the plus. .2260. Now let's contrast this to the TI-84, which is going to be more accurate. It is less rounding. So stat tests z-interval. We had a standard deviation of 1.68, an odd number. If you learned some old school statistics, you'd find why that's kind of interesting. 5.15 was the mean. Sample size was 4,400. And we're doing the 99.7% confidence interval, so 0.997. Forgive me, I can't speak. And then calculate. Close, but again, this is actually more accurate. Anyways, what does this mean? It means we are 99.7% confident that the true population, which would be a parameter, lies between 5.0740 and 5.2260. Alright, 6. A random sample of 20 married women showed the mean time spent on housework by them was 29.8 hours a week. Oh man. I wish my wife did 29 hours of housework a week. I'd have a lot less to do when I got home. With a standard deviation of 6.7 hours. My wife is way on the left of the bell curve on that. I'm trying to find my pen here so I can do some writing. Stinks that I lost it. Give me just a minute, YouTube. Did find my blue pen. That doesn't do me much good though. There it is. So 95% confidence interval, I'm thinking 2 standard deviations. So I'm going to take my mean of 29.8 and I'm going to plus or minus 2 standard deviations, 2 times 6.7 over the square root of 20. It's kind of like the last one I did. 29.8 plus 2 times 6.7 divided by the root of 20 gives me a lower boundary. Actually, that's an upper boundary. 32.7963. It's an upper boundary. The lower boundary is going to be the minus operation. 26.8037. 26.8037. 8037. That covers the 95% confidence interval for the mean time spent on housework by all married women. My wife is not in that interval. 7. A fleet of 100 airplanes has an airtime, time spent flying, standard deviation of 14.9 hours. A sample of 32 gave a mean airtime of 49 hours. Construct a 90% confidence interval. And this is not in the empirical rule. So it's straight up TI-84. Alright, so N is 32. X bar is 49. And the population standard deviation is 14.9. And we want a 90% confidence interval for the fleet of 100 ships based off of this. So it's straight up stat tests Z interval standard deviation of 14.9, X bar of 49, sample size is 32, and we're doing a 90% confidence interval. So 44.668 all the way to 53.332. And there you go. They're pretty easy. A process has been developed so that can transform ordinary iron into a kind of super iron called metallic glass. Metallic glass is 3 to 4 times stronger than the toughest steel alloys. To estimate the mean temperature at which a particular type of metallic glass becomes brittle, 25 pieces of glass were randomly sampled from a recent production run. Each piece was subjected to higher and higher temperatures until it became brittle. The temperature at which brittleness first appeared was recorded for each piece in the sample. The following results were obtained. 480 degrees Fahrenheit. That's a typo. And S, which is my standard deviation, is 11 degrees Fahrenheit. Construct a 95% confidence interval to estimate the true mean. Let's see. N is 20. Now 9.5 is a bell curve thing. That's 2 standard deviations. So I'm going to do this one by hand because I can. My interval is going to be the mean that should probably say X bar. So 480 plus or minus 2 standard deviations, which was 11, divided by the square root of 25, which is 5. So this is going to be 480 plus or minus 22 over 5. I don't know why I'm doing this in a calculator, but whatever. 484.4 is the upper boundary. The lower boundary should be about 475 something. Let's see if I'm right. I'm tired, but I'm not this tired. 475.6. And there you go. The true mean for that process lies between 475.6 and 484.4 degrees Fahrenheit. The U.S. Bureau of Census conducted a survey of 5,000 people and found the mean income for people with a bachelor's degree was $38,000, blah, blah. It is known from previous studies nationwide that the standard deviation income for a person with a bachelor's degree is 6340. Construct a 98% confidence interval for mean. The mean income nationwide for people with a bachelor's degree. This is obviously a dated question, but that is not on the bell curve or the empirical rule. So TI-84 takes over. Tests, Z interval, 7. And let's see here. The standard deviation is given as 6340. 5,000 people were in this sample, but the average was 38,973. There were 5,000 people in this sample, and I am doing a 98% confidence interval. So between 38,764 and 39,182. It's obviously an old question. It's not the kind of question that makes you want to get a bachelor's degree. All right. Then we have the EOC practice. Cafeteria food manager studied the lunchtime eating habits of a group of employees in their office building. The purpose of the study was to determine the proportion of employees who purchased lunch from the cafeteria, brought their lunch from home, or purchased lunch from an outside vendor. The collection of data would best be classified as probably an observational study. Given P is not Q, P is 1/2 of the Q expressed in logarithmic form is equivalent to. Again, remember that log is bay. So here's my existing thing. The base is 1/2. The exponent is Q. Which means that the answer must be P. So when I plug this stuff in, I'm going to have a log, base 1/2. Its argument is the old answer, P, and it has to equal E, which is Q. So log base 1/2 of P is Q. Which graph best represents the graph of f of x equals x plus a squared times x minus b? Now, for your zeros or for your roots, you think about x plus a squared, or just x plus a equals 0. And that says x is negative a. Now, that factor had an exponent of 2, so it touches the x-axis on the left, because x is a negative number. Here we're on the left, but we're not touching, we're crossing. Here we're on the left again, but we're not touching, we're crossing. It makes it choice 1 or 3. Now the other guy says x is b. Think about x minus b equals 0. So x is b, positive. It's still a choice between one of these two. The big thing here is the power function. This is something squared times something. This is x to the second times x I can type, which is equal to x to the third power, which is a function that you memorize. X to the third power starts low and ends high. End behavior, which is something I really tried hard to get you all to get, but you just resisted me over and over and over. There you go. The equations y equal 3t plus 6 and y equals 1.82. I'm out of time. Bell's about to ring. I will have to finish this later.